This is memory. I'm going to walk through how you can create your own. This is a perfect project to dive in and learn more about Unity. It's also scalable. We have easy, medium, and hard options. And so we will change the size and the amount of cards or tokens in the game depending on what the user selects. Let me demo this awesomeness first, and we're going to start with easy. All right, so just 8 tokens, and I have 1 click. It keeps track of clicks, so you can figure out, well, it keeps track of how many cards you overturn, how fast you are at memory, maybe how good your memory is. Notice I can't turn over more than 2 cards at once. Finally there's a match, and I can keep going here, not a match. Boom. That's the easy version of it, 17 clicks, not great. Let's go ahead and show you medium real quick and hard, and then let's dive into the code. So here's same idea. Ooh, I already got a match. All right, and then watch this. Whoops. With how many tokens there are for hard, it will take considerably longer. Okay. And so this will help you understand how to use sprites, how to use game objects, how to live update scores and things of that nature. Let's get going through some of the code. Okay. So there is only one scene. Oh, and I should say all of this code, all of my assets are going to be linked in the description. All of my assets are either Creative Commons or public domain, and all of the code is there as well. So make sure you check that out. Let me just push this over some, and let's take a look at code. So 2 main elements to the code. There's a main token, and I can show you all my assets here, scripts. There's main token, and that goes on our default token, which is here. And it's actually hidden outside the scene. I just used an actual game object, and then I am cloning it, right? I'm instantiating it to create the other tokens. And then the other script is game control. So on game control, we can start with the token actually. So what's happening mainly with our token here is going to be, what's happening with our token here is the literal flipping of the coin. So game object, game control, that's just the game control script over here. I need to grab that later on. Sprite Renderer, all right, so the Sprite Renderer, guys, is the method, is the feature, is the class that can actually create the render of the sprite, the image. It's what you can use to pop the image onto your game object. Public sprite faces, what this is let me go to my token here. And on my main token script, here are my 12 faces that I have, right? And then here's the back of it. The face index right now is just set to 0. Size is how many things I want to have here. Matched is just true or false. That's whether we have found a match. Now, these are available here, for instance, match, because I made it public. I probably don't have to do that for match, but it does give you a good idea of how to make stuff pop up over here. I attached a script. I hit add component. Once I hit add component, I typed in main token and hit create and started adding this code. So, all right. So I have a public void on mouse down. When the mouse is clicked, we'll hit these other items as we go through. When the mouse is clicked, first thing I do is say, hey, is this coin matched? Because if it's matched, we don't want the user to be allowed to turn it over. So is it matched? If that's false, hey, is matched false? If it's false, we dive into this part of the code. Game control script equals control.getComponent game control. I'm just grabbing the script of the game control right here. And why I'm doing that, you'll see. So if the sprite renders on its back, so first I'm checking if it's front or back. Am I turning this coin over, or am I taking a look at the face? So if the sprite's on its back, we want to see the face. So what I do then is if control script token up this, and what that does, control script's over here. So let's go to that function. If control script token up, that'd be here. So I pass the token. This means that token itself. I pass that as an object. I have this Boolean value card flip true. So I'm checking if token up equals null, token 1 up equals null, then I save that token within our game control. Or if token up 2 equals null, then I save it. If token 1 up and token 2 up are both not null, so if neither of these are true, the computer says that's not null, I'm not doing that if. The computer says this isn't null, I'm not doing that if. It's going to default to the else. Flip card becomes false, which is telling us, hey, false, token up, you can't turn this token up. And flip card is then returned as false. So if this gets returned false, we say, nope, you can't turn it up, you have 2 tokens up already. If it gets returned true, token up, yep, you can turn it up, we take our sprite renderer, we say grab the sprite of it and set it to faces.index. Faces, again, on each token is this stuff, is all these images. And the index, the token's face value for that round, is set within game control. We'll see that in a moment. All right, and then control script check tokens. So right after I flip it over, what do I run? Oh, control script check tokens. Well, what is that? That's me checking if there's a match. So first, this is when I add to the click count, because we're keeping track of each time they turn a token over, so the user knows how many tokens they flipped before finding all the matches. So I say add to the click count, update the click count text. I have to turn that to string, our variable click count to string, to update this text. If token 1 up is not equal null and token 2 up does not equal null. So before I check the tokens, first I make sure that they're both actually equal to a value. No reason to check if they're matched if neither or either are not equal to a value. Then, so I know, okay, that's not null, and they match each other. If their face index is the same, if this number's the same, right, maybe it's 6 for the frog, we know they're matching. So if we then set token 1 up match to true, so this becomes matched, and token 2 match to true. Then we null out token 1 and token 2. Token 1 and token up 1, token up 2 is null. That means this now can be given another token. You can continue to flip over tokens, but we leave token 1 and token 2 matched as true because that will stop it now from allowing the user to flip them back over. Those are just stuck up because each time they click, if matched equals false, well now it equals true, they can no longer flip those tokens. Other items I'm going to want to point out, private void awake. This game control, object find game control, we need to do this within an awake function because we cannot do that at the top of our code. We need the scene to be set up before we go grabbing this and defining what game control is. Same with Sprite Renderer. So I declare the game control object and the sprite renderer object up here, but I don't define it until my awake function. All right, now let's move it on into the game control script. And what game control is right here. And notice it's not really tied to any particular thing, right? It's just out here, and it is going to be, well, the control of the game. What it knows, though, is the click count. It knows the easy button, medium button, and hard button, because it's going to set up the start of our game, depending on what the user clicks. Now, there's a bunch of variables here. Don't get intimidated by this. First is our token, right? So the initial start token, like I said, because we're going to clone that to create all of our tokens. Next up is where we're counting how many clicks they have on tokens. Easy button, medium button, hard button. That's pretty straightforward. Medium, hard, right? Token up 1, token up 2. So that's the tokens that we're seeing. Once they click on a token, once they flip a token over, we set the token up 1 or 2 equal to that token. Face indexes, where I'm getting this, is right here. 0, 1, all the way to 11. And notice I put each twice here because we need 2 of each. So we'll need 2 eagles, 2 bears, 2 of each to match. So here's a 0, and here's a 0. Here's a 7, and here's a 7, because each will need a match. Now, if they click on easy, we would only go up to this point, right? Because we're only, oh nope, we'd stop at 0, 1, 2, 3. There's only going to be 8. If they click on medium, there's 12. Hard, there would be... so, yeah, 4 different coins. If they click on medium, there's 8 different coins, but 16 total. And hard, there is 12 different coins, 24 total. This is the random button you want to use. the random generator. And what that is going to be used for, well, you'll see. Same with shuffle, it's going to be used for assigning those sprite values. Float token scale, okay, this is what we use to change the size of the actual token, the card that they're matching, depending on if they hit easy, medium, or hard, to make sure we can fit all this stuff on the screen. That's also what I'm going to do with the Y start value. Okay, so that's going to get changed at 2 points. One, depending on easy, medium, hard, and then also depending on what row we're on, if we're making 2 rows or 4 rows, so on and so forth. Number of tokens, pretty straightforward. If it's on easy, it's 8, so it's 1, 2, 3, literal the first 8 spots, or 0 through 7 indexes. And that will change if it's hard, it's 12. Why change again? That's what I was saying. That is the amount that we need to go down by for each row. And then private int click count equals 0. This up here is the text where the click count goes. This is the integer where we keep track of it. Okay. Click count goes here, right? The actual text, that's what that variable is. Now, let me go down to awake to show you what is happening down here. On awake, all we're doing is finding our token and assigning it. Okay. And then on enable, so when stuff pops up, when stuff starts happening, on click add listener, we add our on click listeners for easy, medium, hard. And notice that these are blue methods. These functions are within Unity itself. All right, let's dive into at the start of the game what's going to happen. Start token count, we set this equal to the number of tokens. The reason I need another variable for this is I need it not to change. So I'm actually going to decrement, I'm taking away from the number of tokens in a bit, so just make sure you have that. Float x position is -6.2. Float y position is whatever the y start value is. Okay, and then I leave this here for actually just ease of access. A row count is equal to 1, so we're starting with row 1. Float, this is what controls the size of the token. Ortho, which is equal to the camera main orthographic size. And what that is, what orthographic size is, it is half the size of the vertical viewing volume. It's a mouthful, but this is how we're changing the actual token size. All right, for integer I equals 1, and yep, I am starting at 1, I is less than start token count plus 1, because I need to start at 1, all right, I plus plus. Shuffle number, random next. So we're not going to be touching our random variable. This we use their system random generator, okay? And we're not touching that. This is going to be used, we're going to use the methods of random next, 0 number of tokens. So we're getting a number between 0 and whatever the number of tokens we need for the game is. And we're assigning that to shuffle number. We're not assigning that to random. We're going to keep using random as is. So now our variable temp is going to instantiate. It's going to be a clone. An instantiate is an object that only exists while the game is being played. So when I hit stop, it disappears. All right, it's going to be a clone of our token. And where's it going to be located? At our X position and our Y position. And those will be changing based on easy, medium, hard, and based on what row they are in with the token placement. And then the Z is just 0. Quantian identity. This is the rotation of the coin, essentially, and we don't need to worry about that. So temp get component main token. So we're grabbing the main token dot face index. So that temporary, that clone we just made, whatever it is, maybe it's the third token, we're going to set the face index equal to shuffle num. Shuffle num, remember, is the random number we just generated. Once we do that, we need temp transform local scale. Hey, change the size. And what I'm using here is what I calculated with ortho, right here. Token scale, ortho, token scale, 0. Okay? And so that's what's going to keep the size, the scale, at what we need it to be. And look at token scale here, right? Token scale is set up here, but it's also set when they hit easy, medium, hard, and I'll show you that in a sec. Face index dot remove face index shuffle number. So I'm going, whatever number I just assigned to our token, I remove it from this. And this is how we're randomizing it, right? So when I get a random number and assign it to shuffle temp, that is not the index assigned here. I take that number and I say it's a 5, right? We're not going to assign 5 over here. What it does is go 0, 1, 2, 3, 4, 5, and it would assign a 1. Once it assigns that 1, we remove that from the faces index, so it's gone. We get rid of it to make sure we only assign the 1 the correct amount of times. And then we decrement, we take 1 away from number of tokens, because now we're going to only have random numbers 0 to 7 or 0 to 3 or 0 to 2 as we're assigning face values, face indexes, and removing them from our list. Now our list, even when it's on easy, will have all of these numbers, but we would set the number of tokens to only be 8, so it's not going to use these other numbers, so it won't matter. All right, and then x position equals x position plus 4. Okay, so we're just adding 4 to the x position. We're pushing that token over. And then if I divided by 4, so if it's 4 tokens, is less than 1, meaning not divide, what this is doing is we're getting the remainder. So if I divided by 4 has a remainder of 0, so if it's 4, 8, 16, so on and so forth, then if its remainder is less than 1, it's 0. What we want to do is y position equals y position plus y change. So whatever I set the y change to be, it's going to go down by that much, and the x position is going to restart at negative 6.2. Then we let the computer go ahead and add to the row plus plus, to keep track of the row we are going to be on. And it looks like this might not even be used. However, I'll leave it there. All right, and then what do we finally do? Token set active false. What this is the original token over here. We're deactivating it. It's not going to be used, but we use it to clone. All right, now let's go to the easy, medium, hard buttons. So if they click easy, hide buttons, we're going to hide these buttons, start game. Hiding the buttons also will hide all of these little icon things, and start the game. We don't need to change any of the variables because I set the default numbers here to be easy, the y start value and all of that. Now if they click medium, for example, token scale, we're changing the size of our tokens. We are y start, we're changing this, right? Number of tokens is now going to be 16. And then we're going to also change the y change value. So how close together the rows are, and then we start the game. And we're doing the same thing here, right? A higher token scale number, remember that's used to divide. So the higher the number, the smaller the token. Changing some start values and change values. All right. So now that we got the game set up, how is it actually getting run? Well, we went through some of this. So when the user picks token down, what happens? Right here, Sprite Render. So if they click on the token, it is not matched, and the Sprite Renderer does not equal back. So that means it is face up, the else will run, Sprite Renderer changes to back, and then we run control script token down. So to put a token down is run. If token up is equal to token up 1 is equal to temp token, because we passed the token. So we're just checking, hey, is this the token 1 for now, or the token 2 for now? And whatever it is, if it's 1, we now reset token up 1 to null, or we reset token up 2 to null, right? Because we need these null if they flipped it over to the back. Because having them null is what is checked when they're trying to turn over a token. So we need to make sure we're always keeping track what tokens are up. That way, if there are 2 tokens up, they can't turn anything over. But if they flip one over and set it to null, we can allow them to turn a token over. Check tokens I already went through, right? We're checking if they are actually ready to rock, if those are equal. And that is what increments, that's what adds to the count of how many clicks. Token up we went through as well, whether they could flip a token or not. So that is going to be the code for the game. I need to point out a few things within the game itself. All right, For game setup, make sure you have this. To click on something like our buttons or our token, you need a circle collider 2D, or the buttons aren't circle, the buttons are, oh, the buttons can be clicked on, right. Buttons can be clicked on without a collider, but for a token, you definitely need to have that collider functionality, okay? And now for the buttons, you do want to go ahead and position them. I just clicked on this, I held Alt, and I picked their position, and then I messed with the numbers to get them where I wanted. These start images, what I do to get rid of those, on hide buttons in here, hide buttons. So I set all the objects active or the buttons to false, and then game object start images, and I grab game object find objects with tag. And what that is right here, I just clicked tag, add a tag, I added start image, and then I added it to each one of these. And so I grab those with the start image tag for each game object item in start images in this array of objects. I destroy that item. And that's what's getting rid of those for us. I set my screen size to 16:9, and then I wanted it set to scale with screen size. And with that scenes, you will have a matching game. An exciting, fun matching game. And I'm going to play a round or two, and all of this material, again, is posted in the description, ready to rock. You should make one. You should make one super duper awesome, maybe even better than mine, and tell me about it below. If you're watching this, if you're still watching this, make sure to hit like, make sure to hit subscribe. I'm really not doing well here. It gives me warm fuzzies. It is helpful and encouraging and kind. I'm still not doing great. Hopefully, the randomness of this is brutal. 2. All right. Regardless, make something cool. Tell me about it below. And I'm going to keep going.